Alright, let's begin with question number 1. Let R be the region bounded by y equals square root x and y equal to e to the negative 3x and vertical line x equal 1. Find the volume of the solid generated when R is revolved about the horizontal line y equal 1. So this time we are going to have a horizontal line y equal 1 as the axis of revolution. So now we have to draw the line y equal 1. So y equal 1 is right here. We're going to draw this way. Let's see this point. So we get square root 1 equal 1. So this is 1 comma 1. So the line is going to pass this point. Y equal 1. Now this is the axis of revolution. So that means this time you're going to revolve this way. We are still going to have circular motion. So now let's see, we're going to have 1 radius or 2 radii. So this is the axis of revolution, and we had the shaded region. That some space between the line y equal 1 and the shaded region. So therefore, we are going to have 2 radii, the small radius and the big radius. Now we are going to draw the small radius. You always put the dot or the center of the circle at the axis of revolution. So let's pick a point over here. Never pick a point at the end points, always in the middle, so you can see the radius. Now we are going to draw the line. So because the curve are below the y equal 1, so we have to go this way. As soon as you hit the first curve, then you stop. So now we get our small radius. So the small radius is between the line y equal 1 and the curve y equal to square root x. So we say r equal to the distance between the axis of revolution y equal 1 and y equals square root x. It's always the distance between the curve and the axis of revolution. So this time the top is the axis of revolution, and then the bottom is y equals square root x. So r equal 1 minus square root x, top minus bottom. So we found our small radius. So next we are going to find our big radius. So now I'm going to change the color. I'm going to draw from the center of the one that you chose and then go down. And this time, then you will find out that the big radius between y equal 1 and the outer function, the outer curve, y equal e to the negative 3x. So we say that the big radius, r, okay, this r is a big radius, not the shaded region r, even though we use the same letter. It's the distance between the axis of revolution y equal 1 and the outer curve y equal e to the negative 3x. So the big radius equal top minus bottom, right here, this time top, bottom. So you're going to have 1 minus e to the negative 3x. So we found our small radius and the big radius. Now I'm going to draw one cross section. It's kind of difficult. So now you're going to go this way. So we are going to have our first inner circle, and then I'm going to draw the big circle. You have to go this way. All right. Today I'm not going to draw the entire 3D diagram. It's kind of difficult to draw. So as soon as we found the big R and small r, then we're done with the diagram. Now we are going to take a look at the cross section. It's a big circle and small circle. So the area of cross section equal to pi big R squared minus pi small r squared, because big circle and small circle, and then you have to subtract. Okay, so you're going to have big R, small r. Now So the volume equal to the integral a to b area of cross section dx. That was the general formula that we learned. So because the area of the cross section is pi big R squared minus pi small r squared, so therefore we're going to do integral a to b pi big R squared minus pi small r squared dx. And I'm going to factor out the pi because they have a pi in common. So pi times integral a to b big R squared minus small r squared dx. Now we are ready to do substitution. Pi, and then we need the a and b. So some people have a hard time finding the a and b, so let's go back to the diagram to see. Okay. This is the shaded region. So the shaded region started from here, and then you continue this way and stop at x equal 1. So that means we know that the biggest number for x is 1. I need the smallest x value. So that depends on the point of intersection. So this x equal will be my a. Okay. So I need to use a calculator. So you're going to type in y equals square root of x, and then y equal to x, y equal to e to the negative 3x. Okay, y equals square root x, y equal to e to the negative 3x. In window, I use 0 to 3, negative 1 to 3 straight up. So now I'm going to graph, and we're going to find the point of intersection. So this is the point of intersection that we're looking for, so we're going to find it. Okay, so now I'm going to copy down the point. So this point is I only copy down the x value because I don't need the y value because we using dx. I only need the x value and the x value. So this x value is 0.23873413. So the a is this x value. So now I'll go back over here. I'm going to use 0.23873413 to 1, and then big R squared. So 1 minus e to negative 3x squared minus small r squared. And holding times dx. I'm going to type in this holding in my calculator. I'm going to use the y1 as my big R. So 1 minus e to the negative 3x. And then 1 minus square root of x as my small r. Now I'm going to go back to the main screen. Math 9. y1 square minus y2 square, and then dx. So pi times this number I know it's not going to be a fraction because I have e to something and square root. Now I'm going to convert this whole thing into decimal, so I'm going to times pi. So we got 1.42358.479. So we finished. Now let's go to question number 2. Find the volume of the solid generated when R is revolved about the x-axis. So this time, this is the axis of revolution. So axis of revolution. It's very important that you identify the axis of revolution so you know where to start to draw. And we had to know the equations is y equals 0 because x-axis. So now this is going to be the shaded region. So I'm going to pick a point in the middle. So this is going to be the center of my circle. So now all this curve are going to be above the axis of evolution. So I'm going to draw this way. So start over here. As soon as you hit your first curve, you stop. That is the small radius. Okay. So now you are going to say the small radius equal to the distance between y equal e to the x over 2 and the axis of revolution, y equals 0. So therefore r is going to be top function minus bottom function. So top function is y equal e to the x over 2, bottom is y equals 0. So e to the x over 2 minus 0, simplify. So we got r equal to e to the x over 2. Now we are going to draw the big radius. Now we are going to begin over here, and then you are going to have your big radius, okay? So radius. So the big radius r is equal to the distance between the top function, which is the outer one, y equal 1 plus sine 2x, and the axis of revolution. Okay, it's always between the curve and the axis of revolution. And this time is y equals 0. So now we got r equal top minus bottom, 1 plus sine 2x minus 0, simplify. So now we found our big R and small r. Next we're going to sketch one cross section. So it's going to look like this. So we still have big circle subtract the small circle. So now we are going to say v equal to integral a to b area of cross section dx. Integral a to b. We have big circle subtract small circle, so therefore pi big R squared minus pi small r squared dx. Factor out the pi. Okay, so a to b big R squared minus the small r squared. Now we are going to find what is a and b. So here, this is the shaded region. So it starts from here and then you move all the way to the other intersection point. So this point is already given, is at x equal to 0. Okay, so x equals 0 and a equals 0. I need to find this point. It's going to be b. So we need to use our calculator to find the intersection. So we're going to type in 1 plus sine 2x e to the x over 2. And my window is 0 to 3, negative 1 to 3 is good enough. Now we're going to graph. So this is going to be the point intersection. So we're going to find. Okay, so now I'm going to copy down the point. So this point is 1.1356925, comma. I'm going to write down y. The reason is I don't need a y value, I only need the x value. So this is the x value. So b equal 1.1356925. Okay, so you had your a and b. So we had 0 to 1.1356925. Now we're going to do r squared, big R squared, minus small r squared dx. Big R, 1 plus sine 2x. Small r, e to the x over 2. Now I'm going to type in this in my calculator. So I already had my 1 plus sine 2x, and e to the x over 2 as a y1, y2. So now we just go back. Okay, so map 9, 0, 2. And then we have y1 square minus y2 square dx. And then enter. I get 1.35A0A. Okay, let me copy down this. So we had 1.35A0A3936. And I know it's not going to be a fraction. So therefore, I am going to type in times the pi. So I get 4.2665. So we turn into 4.2665. So we finished question number 2.